Hello my dear students, welcome to one more amazing session from Sri Chaitanya Academy Infinity-level NEET YouTube channel. This is Suresh, Faculty of Chemistry. So in the CBSE NEET examination series, we will be discussing D and F block elements. This is most important topic in the CBSE exam. You will be having 1 mark, 2 mark and 4 marks reasoning type questions, direct NCERT applications. So, hi Radhika. All my students, those who are online, please like the session, share with your friends and subscribe to the Infinity-level Sri Chaitanya Academy YouTube channel. So, without delay, we should start the session. Pacha. Okay. So, hi, simply say hi, those who are online, so that it is a live interactive session, so we can have a discussion among we and you and me and all the students. Okay. So, hope you are preparing for your physics examination right now in the CBSE series, and of course, some time is there, so we can have a couple of chemistry sessions in between. So, why these transition elements are more important? It is first of all theory oriented inorganic topic. अगर inorganic topic आएंगे तो आपको मिलेगा P block and D and F block and complex compounds का भी. And it gives the most important aspect is direct straight away NCERT based questions. Hello Geeta Madhuri, I miss you nowadays. How are you? Fantastic to see you that you're in the class. How are you doing chemistry, Geeta Madhuri? And I request all the students who are there in the session, please just like the session so that we can start transition elements. In the entire periodic table you can see, I just highlighted here. These elements are called S block elements. How do you say it is an S block elements? The differentiating electron enter into the S orbital, and these elements, so what you can say, it is a P block elements, and of course these are F block elements, and these elements are called D block elements. So depending upon the orbital it is filled in the electronic configuration of an element. The entire periodic table is divided into S block, P block and D block and F block. Bacho, here you can see, I want to give more emphasis on the D block elements. Okay, so the D and F block elements are known as a transition. D block elements are known as a transition element. F block elements are said to be inner transition elements. Generally, D block elements are called transition element because their chemical properties are in transition between S block element and the P block element. And Geeta Madhuri, I am fine, thank you. Doing previous year questions in botany, zoology and chemistry in exam almost near. So NEET UG examination 2026, all the best. And from now onwards, the session will be every day. So in this YouTube channel, here I can say Geeta Madhuri and many students like Betu and that they're connected with me since almost a calendar academic year, and they joined in the YouTube channel and they improvised their chemistry like anything. So those students, please come and join with us and improve your score in your CBS examination as well as a NEET examination. Bacho. And always keep smiling and take your mind in a steady, tranquil position and never go into the pressure, because pressure इसी समय से आपको पढ़ने का ज़्यादा संभावना है. So he never give an opportunity to increase your pressure levels. So you studied so far, you made a lot of efforts, and that was a chapter. Now the chapter begins from this February onwards. When the board examination comes, the board examination as well as NEET examination together, along with the crunchy timetable and clumsy schedules, and this is a chance where you are going to improve the marks, as well as there is a chance of a pressure. So never come with your pressure, right Geeta? Yes, you want to give a request, do exam 10 days before, how to bubble in the error. Yes, I still remember your request. Actually, how to fill the OMR sheet and how to bubble it and how to avoid the mistakes in that, I am going to conduct a session just a week before your NEET examination. Happy? Even though we marked right option, yeah, exactly. However, you mark right option, you are going to get 0 mark or a negative mark because of the error in the bubbling. So bubbling is the game changer. I know it personally. Okay, anyways, every D block element is not a transition element. I am going to say that. Okay, so the transition known as the transition metals, they are transition metals because all elements are metals. Metals that have incomplete D subshell. If you check the electronic configuration of iron, it is 3d6, 4s2. So you have D orbital is incompleted. Bacho, if you say Fe3 plus, it is also incompletely D orbital. So the element should have incompletely filled D orbitals either in the ground state, mean to say normal electronic configuration, or else you can expect a incompletely filled D orbital configuration in any stable oxidation state. Hi Alam, complete theory plus PYQs NEET के लिए definitely we take a rapid revision of NEET examination syllabus and PYQs also will be given. Okay, so stay tuned in the class everybody and take a pen and paper. I am going to give a short tricky points. So these tricky points can elevate your marks potentially, and I request all the students, those who are online right now, please like this session so that session का जोश भी बढ़ जाता बच्चों. You can see here F block elements जैसे D block elements के हैं and D block elements as D orbitals are filled, F block elements F orbitals are being filled. They have inner transition elements, they have 4F series and they have 5F series, cerium to lutetium and thorium to lawrencium. So two types of inner transition elements are seen. Here you can see every element of the D orbital, D block is not a transition element. Zinc, cadmium, mercury is not considered as a transition element. So why? CBSE में एक reasoning question आ सकता, NEET examination में assertion reasoning questions भी आ सकता, and CBSE question paper में assertion reasoning भी आ सकता. So before you jump into a particular topic, you need to know what exactly. So zinc ground state में D10 है, zinc का जो compounds है उसमें stable oxidation state zinc 2+ होगा, उसमें भी zinc has D10 orbital. So that zinc is not considered as a transition element. You have to write the electronic configuration and present it nicely. When you write the CBS examination, presentation skills are very important. And cadmium 4d10 and cadmium 2+ फिर भी 4d10. So d orbital पूरा भरा हुआ, d orbital वेकेंट रहना चाहिए कम से कम एक ही ऑक्सीडेशन स्टेट में, ताकि ये आपका मेटल ट्रांजिशन मेटल होगा. 9th like done, fantastic. Array 105 views are there, only 9 likes are more likes are required. Done. Just say एक like mark, एक thumbs up and fire emoji in the chat box so that we can have mercury 5d10 and mercury 2+ भी 5d10 है, stable oxidation state पकड़ना पड़ता. And when you say silver, copper and silver are considered to be transition elements because silver you have 4d10 configuration. So you want to disqualify silver into its transition element category? Not possible, because here silver plus, we know silver nitrate is a popular compound, silver chloride is a popular compound, उसमें silver का जो oxidation state वो silver plus होगा. If it lose an electron, it is going to have फिर भी 4d10 configuration है. But you have Ag2+ ion, AgO is there, but of course is unstable. You can see incomplete d orbital configuration. You will be having a clear picture about that. Whenever you have incomplete d orbitals, you can say it is a transition element. So let us talk about the transition elements. Let us go back here. If you talk about the copper, you are going to get argon 3d10, 4s1, कॉपर का अलग कॉन्फ़िगरेशन, एक्सेप्शनल कॉन्फ़िगरेशन भी है। अगर कॉपर 2 प्लस यू से इज ए स्टेबल कॉन्फ़िगरेशन, आर्गन 3d9 4s0, so 3d9 is incompletely filled shell, right? And moving ahead here, transition element, let us talk about the position, electronic configuration, general properties, जो भी general properties है, एक ही लाइन लिखना, I am going to give you that. So general electronic configuration of the transition element is going to be n minus 1, 1 to 10, ns 0 to 2. यहाँ पर NCERT का हिसाब से ns 0 to 2 भी वैलिड है। You can write this and you can write this, दोनों बराबर है। क्योंकि जीरो कैसे हो सकता है, पलाडियम का हिसाब से आप जीरो लिख सकते हैं। So inner d orbital, scandium you have d1 configuration and cobalt you have d7 configuration. So the last electron, that is called differentiating electron, enters into the d orbitals, ताकि ये वाला d orbital element can be a transition element. So Geeta Madhuri, Alam, so whatever you want for requirements, you please mention something in the chat box, so that I am going to take this point into the consideration and I will deliver according to your request. So this is a NEET YouTube channel and these sessions are going to be on the YouTube channel absolutely free. हम बच्चों के लिए कुछ भला करने का कोशिश कर रहा हूँ बेटा, आप भी थोड़ा भला करने का कोशिश कर सकते हैं। So we don't want anything from you, थोड़ा सा like मारो and subscribe to the channel, so हमको अच्छा भला होगा. And you can see here for 3D series elements, the d orbitals are being filled. In the entire transition series, you can see in this periodic table, if you have a yes, this is your periodic table. In this periodic table, बच्चों, scandium to zinc 3D orbitals are being filled. So that is called first transition element, that is called 3D series. उसमें 4D orbitals are being filled, उसमें 5D orbitals are being filled, इसमें 6D orbitals are filled. Here lanthanum से आपका inner transition element चालू होगा hafnium तक, actinium से RF तक. Okay, moving ahead, I am going to show you the total architecture about this. And let us talk about the electronic configurations and all various elements. You know how the elemental configuration is given, and this elementary electronic configuration is the key point in deciding their oxidation state, the relative stabilities of their relative compounds, oxides, fluorides and their compounds. So in the general properties, transition element exhibits certain characteristic property, certain characteristic property due to incompletely filled d orbital, bachcho. So which I want to classify into physical properties, atomic properties and chemical properties. So let us see in detail version of this. So all the metals are going to be hard and rigid metals, and they have high tensile strength and high thermal electrical conductivity. They have malleability, ductility, metallic cluster, hard and less volatile, high MP and BP भी हो सकता है. I want to show you the various properties that you experience it and you can feel it. And high electrical conductivity, we use copper wire at a domestic level. Aluminum wire is also conductor, but we use copper wire preferably. They have high tensile strength. And also they have the highly malleable, you can hammer the metal and you can draw into a sheet, that is called malleability. They have a metallic luster, gold itna anmol hai. So they are not volatile, they can be drawn into thin wires, they are ductile and malleable, right? And also they have high melting points. Metals have generally high melting points and boiling point. Everything we'll discuss it. And you have, so the melting point and the boiling point of the transition metals. So whenever you have unpaired electrons in the d orbitals, the metal bond is formed by, you have n minus 1 d electrons ns electrons. Okay, 1 to 10 electrons. So these electrons are going to participate in a metallic bonding, and these electrons are going to be participating in covalent bonding. As the number of unpaired electrons in the d orbitals increases, the covalent bond strength increases and the metal has a high melting point. Always melting point is directly proportional to intermolecular force. It is any part of chemistry, it is important, right? And we'll go more detail about this. Here general rule, greater the number of unpaired electrons, that is the logic. Greater the number of unpaired electrons, bachcho, higher will be the melting point. You can write the electronic configuration, scandium, titanium, so up to zinc. Up to D5, number of unpaired electrons increases. So the melting point increases. From there, number of electrons that is available for unpaired electrons decreases, so melting point decreases. So in any row, 3D metals rise to be the maximum at a D5, I said, and then fall regularly. So there are some anomalies are there when it comes to the manganese and technetium. Jahan par anomalies, abnormalities and exceptions are there. Okay, NCERT and the CBS examination जो भी है and NEET examination वहाँ पर आपका question आने का बहुत chance भी है. So let us see the graph over here. What is the observation I can see in the melting point scenario? It is 3D series, 4D series, 5D series. So that 5D series is greater than 4D series is greater than 3D series. It reaches to the maximum and is coming down. But there is an exception in the manganese because of the half filled D5 orbitals and 4s2 configuration. And here transition elements have high boiling points due to high enthalpy of atomization. So what is the meaning of enthalpy of atomization? Solid is converted into gas, that is delta H is called positive. This value is called enthalpy of atomization due to strong metallic bonding and intermolecular forces. So the enthalpy change, breaking of 1 mole of bonds completely to obtain its gaseous phase is called as enthalpy of atomization. So recall thermodynamic grade level. So we are connected to all the aspects of the total syllabus. बच्चों समझ में आ रही है क्या? अगर कुछ डाउट है ना तो चार्ट बॉक्स में देना यार. Transition metal exhibit higher enthalpies of atomization due to effective nuclear charge. If its effective nuclear charge increases, intermolecular force increases, enthalpy of atomization increases. So they form very strong metallic bonding and are due to whatsoever the property due to unpaired electrons in the n-1 d shell. So you just write anything and come to that point and conclude जब आप CBS examination descriptive question आप लिखना चाहता हो तो. And this is the point. You can write in active voice, passive voice and reconstructed statements. जो भी है आप ऐसे ही लिखना है. All the best for your all examination. Greater the number of valence electrons, bachcho, stronger is the resultant bonding. So higher will be the boiling point. Everything related here, bachcho. Right? Geeta Madhuri, you stopped asking doubts. Okay, so one request as per new NCERT upload syllabus topic in chemistry, I mean upload new changes lines in chemistry, please provide PDF. Okay, everything is kept in a PDF and uploaded in the Telegram channel. You can join in the Telegram channel and you can download that. It is already uploaded, Geeta Madhuri. Fine. So moving ahead. If you say the boiling points, here it is going to be 5D series is greater than 4D series is greater than 3D series. So the maxima, so maxima reaches and it is gone down. So the maximum at about the middle of each series indicates it is a D5 configuration का मुकाबला है, right? So D5 configuration makes it more favorable for interionic interactions here. So among zinc, cadmium, mercury has the low boiling point because they have the zinc का 3d10 का 4d10 का and it is going to be 5d10 ka. So 0 unpaired electrons, weak metallic bonding and lowest boiling point. They are volatile metal. They are volatile metal. Okay. Now please write is 1s, 2s, 3s, 3b orbital filling sequence. Geeta has a big doubt in that. Okay. Refer Moiler diagram beta. In that you see, as you asked, I need to tell 1s, 2s, 2p, 3s, 3p, 4s, 3d and it goes to 4p. आप कुछ आंसर लिखना चाहते हो कॉम्प्लेक्स कॉम्पाउंड्स को भी you follow up to here. Fine. I mean sequence of 1s, yes, that is called NLX method of writing electronic configuration beta. ठीक है? That's good. So let us talk about the atomic properties. Atomic properties like atomic radius, ionization energy काफी important है, electron potentials as well, standard electrode potentials as well. बच्चों, let us go ahead. In this case, what I can say here, this is about the atomic radii. So it is scandium, so 3D series, 4D series and 5D series. So 3D series, 4D series, 5D series. So it is coming like this, but 5D series, 4D series का value काफी बराबर देख रहे हैं. क्यों? Yes, atomic and ionic radii values decreases generally from moving left to right in the period. Of course, it is decreasing. Yes, it is decreasing. Thank you very much. God bless you for your gratitude. And I can say the observation, the atomic radii of the elements from chromium to copper are very close. You can see chromium here, from here it is decreased. Chromium to copper is very close, right? Because screening effect, because of the screening effect, right? That's very important. These are the observations. So how to read the NCERT book? NCERT से क्रॉप करके ये इमेज बनाया मैं, ये NCERT से निकला. Then you have to observe this variation, and that includes your smartness. You are more smarter than me. And थोड़ा सा कॉपर से जिंक तक है ना, थोड़ा सा बढ़ गया. क्यों? Radii of the 5D series. So why? Because there is a sudden increase. D10 configuration is there. Everywhere it is observed. And you can see 5D series elements are virtually the same as that of corresponding member of 4D. I want to say here 4D 5D का जो radius है ना, काफी बराबर दिख रहे हैं. देखो, they are almost the same because of the poor screening effect of 4f orbitals, and due to Lanthanide contraction you can just visualize that. बच्चों, hope you understand. अगर कुछ डाउट है ना तो जल्दी देना बस. And decrease atomic radii in 3D series. So it decreases across the period, scandium, titanium, vanadium, chromium, manganese. Because up to from here to here, effective nuclear charge is going to be overcome this effective screening effect. SE. Screening effect, I think you know, I explained. Due to the poor shielding effect by the d electrons, attraction increased more than repulsion. But here manganese, iron, cobalt, nickel. And in this case, effective nuclear charge is nearly same as screening effect. But here the copper and zinc, due to D10 configuration, so screening effect is going to overcome this effective nuclear charge. So fact is visualized here and the reason is visualized here. अगर कुछ doubt है ना तो जल्दी 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 बोलना. And I want the session to be liked by anybody. Come on, all students. So, bachcho, moving ahead here, this is very important. What is a screening effect? That is very, very important. Nucleus is going to attract the electron, outermost electron. But there is a repulsive electronic force between the inner electrons. So, as a result of these repulsive forces given by the inner electron, the overall attraction force experienced by this outer electron is decreased. That effect is known as screening effect. Okay? And as a screening effect increases, the electron from the outer shell is going to move away from the nucleus, so that size increases. So, poor screening effect means atomic size decreased, screening effect means atomic size is increased. That is the logic. It can answer many questions in any way of the total inorganic chemistry. So, this is the screening effect is the most confusing point. I want to unveil this. So, everybody take a screenshot. What is a screening effect right now? So, take a screenshot of this so that can be your reference. So, screenshot lena hai. 3, 2, 1. Moving ahead, so due to lanthanide contraction, radius of 4D series is similar to that radius of 5D series. यहाँ पे दिखाई दे रहा है क्या बच्चों? So the filling of 4F before 5D orbital results in regular decrease in the atomic size. Zum. So imperfect shielding means a poor shielding. Textbooks writes this term. It is a poor shielding of one electron by another in the same set of orbitals. Fine, beta. Now, let's talk about down the group lanthanide contraction appears. The steady decrease in the atomic size among the lanthanides is called as a lanthanide contraction. The reason behind the lanthanide contraction is pretty clear due to poor screening effect of 4F orbitals. So, you have to use the term steady decrease. So, due to the titanium 4s2 3d2 147 picometers, zirconium and hafnium, and actually hafnium is supposed to be greater than that of zirconium, but zirconium and hafnium का जो atomic size है ना दोनों बराबर दिखता है 159 and 660. So, this is the implementation of a lanthanide contraction, and due to the same size zirconium and hafnium will have the similar physical properties as well as chemical properties. You need to know about that because of the lanthanide contraction. CBS examination में if you jump and dive into the lanthanide contraction, poor shielding effect, everything, shielding effect, screening effect दोनों बराबर है. But the thing is here, you have to mention due to poor screening effect of 4F orbitals, right? Geeta Madre, come on. So, shielding power, जो electron orbital close to the nucleus will have the more shielding effect. S orbital is greater than, P orbital greater than, D orbital greater than F orbital. So, जो F orbital है ना, इसका कम से कम screening effect होगा. So, size decreases, nuclear attraction, outermost shell increases. So, that electron come close to the nucleus, so size decreases. And one more reason, whenever 18 electrons number increases ना, screening effect व crowding ज़्यादा होगा, screening effect इतना काफ़ी अच्छा नहीं कर सकता है. That is called imperfect shielding or poor shielding or poor screening effect. That's the reason why titanium, hafnium and zirconium in दोनों का size is actually titanium, zirconium and hafnium. It is supposed to be like this. उसमें poor screening effect का वजह से ओके इसमें poor screening effect का वजह से इसका रेडियस कम आ रहे हैं सो दैट दोनों का वैल्यू काफ़ी बराबर दिख रहे हैं ओके एंड मूविंग अहेड so in the lanthanide contraction density increases down the group because the atomic size is decreased so density is equal to mass by volume so agar volume decrease hoga to density is increases down the group that's very important here and also you can say trends in ionization energy first of all jab ionization energy comes na it is irregular because regularity irregularity dono ka काफ़ी ups and downs will be there. So in general form left to right ionization energy should increase. Yes, it is increasing. Reason due to the increase in nuclear charge. Electrons are tightly bound to the nucleus and it is going to have high ionization energy. Clear? Any doubt? So this is the live interactive session. I request all the students to be more interactive. So I made a very good presentation that can be visually self-explanatory. Just attend my class and listen my voice and watch the presentation. That itself can indicate yes, you can do the best, right, bachcho? And moving ahead, zinc have significantly high ionization enthalpy than copper because radius of zinc is greater than copper. But ionization energy of zinc is greater than copper. First ionization energy का बारे में बात कर रहा हूँ. Ionization energy inversely proportional to size. So इसका ionization energy कम होना चाहिए. But here, due to the completely filled d electronic configuration, okay, fully filled, more stable and high ionization energy. That makes the zinc is exceptionally has a high ionization energy than copper. So moving ahead here, oxidation states. So the chemical properties, this is oxidation state comes under this form, standard electrode SRP values and magnetic properties, color, formation of complexes, catalytic properties, formation of interstitial compounds, alloy formation. Simply you are asked to write a short notes on the characteristic properties of the transition elements. You have to write this just 8 points. Only the reason behind these 8 points is the transition metals will have incompletely filled d orbitals. That is only the reason can answer all these 8 points. Fine. Moving ahead, oxidation state. Yes, transition metals exhibit different oxidation states. Because they have d orbital जो है ना n-1 d orbital है, ns orbital है, दोनों के जो एनर्जी अंतर है ना कम से कम होगा ताकि इलेक्ट्रॉन यहाँ से यहाँ तक जंप कर सकते हैं and it can happen anything. Example, transition elements will show great variety of oxidation states. Manganese जो है ना it can show +2, +6, +7 भी है. And these are all the electronic configurations. You say D1 and D2, D3, D5, D5, D6, D7 and D8 and D10 and it is going to be D10. उसमें जो है ना number of electrons, unpaired electrons increases. You are going to see the variation in the electronic configuration is same. The common oxidation state सबका +2 oxidation state होगा. But here you can see scandium is the only transition metal do not show variable oxidation state. That is a very important. Scandium do not show. Of course, scandium is a transition metal, but it do not show variable oxidation state because of the D1 configuration beta. Because of D1 configuration. समझ में आ रही क्या? Fine. And you can say transition element can exhibit multiple oxidation numbers. These points can give you the statement based questions. And the most common oxidant state is +2, as the 4s electrons are usually fast to go out. Alam, when you like the button, the like button will be visualized in front of your name, but here please, those who are online, please press the like button. Okay, now you can see because the 4s and 3d orbitals are close in their energy का जो अंतर है ना कम से कम होगा. It means that an electron can jump from 3d orbital to 4s orbital and 4s orbital to 3d orbital. Electronic transitions are possible. Change in the oxidant state of the transition metals often give rise to the color changes during these chemical reactions. That's the reason why copper sulfate anhydrous is white in color, but when you expose to air, it is going to take the water molecule and complex with it is because of this. Okay, blue is going to be changed. They have the colors. Iron 2 plus green in color. During a chemical reaction, it can change its color to iron 3 plus. It can be turned into the brown. That is the meaning of the last statement. Nakibalam. Okay, moving ahead here, some more points. So the common oxidant state titanium +4 is more stable than titanium 3 plus or titanium +4. Various electron, you just memorize the color and oxidation state. And electronic configuration का हिसाब से ये electronic configuration लिखना पड़ता. Okay, so vanadium +5, D0 configuration, chromium +6, noble gas configuration, Mn +7 are extremely stable because of this noble gas configuration. Hi Prince, you are prompting for me. Thank you. And when you see here, scandium requires high energy to remove this electron. So you can easily remove, but scandium plus 4s1, scandium 2 plus and 3d1, that is scandium 3 plus is going to be more stable because it is going to have an organ configuration. Fine, it is going to have an organ configuration. Similarly, inert pair effect, the inert pair effect is actually a phenomenon that happens in the last members of the p block elements, but I want to give you a short point about this. Inert pair effect is the effect that is applicable as a Lanthanide contraction, whatever you can say, that the pair of electrons in the last 6s orbital to unpair in order to get participated in the bond formation, that is called inert pair effect. And lower oxidant states favored by the heavier elements in the p block, because that is due to inert pair effect. And the same implementation can be given, higher oxidant states are favored by the heavier elements in the d block elements, easy to remove the valence electrons, right. For the d block elements, heavier elements means periodic table में lower 6th period का are called heavier elements. D block element तक 6s orbitals can be easily removed. When it comes to the p block elements, 6s elements cannot be easily removed. That is the variation comes in between this. Geeta, all values, sir. One question, please clarify the chemistry NCERT book. There is a ionization and electronegativity values, atomic radius value, all elements must be remembered. No, don't remember. जब टेबल देते हैं ना, टेबल पकड़ के, you see the variation. the variation is regular variation or not, you just identify. If not regular, what is the reason, it will be written there itself. And also, what could be the reason behind the exceptions? So, for that the tables are required to see and study. Studying is different and by hearting is different. Are you getting or not? Clear? Geeta, at least thanks for asking doubts. So, not only Geeta, all the students, please ask doubts. Please ask doubts. Fine, moving ahead, bacho. Stability order. And you can see MoO3 and WO3, tungsten, are not oxidizing agents. Dichromate ion is going to be super oxidizing agent in the acidic medium. So, I want to say here, inert pair effect and its application, let us see more into the S. So, halides of 3D, just enough to have an idea is enough, and yes, that is enough. Mandatory to remember the values? Absolutely no. So, now you can see a metal can have its highest oxidation state when that metal combined with oxygen or more electronegative like fluorine. Fluorine, of course, more electronegative. It can take the metal to its highest oxidation state. When the metal binds with an oxygen, oxygen can form multiple bonds, pi bonds. Because of the bond, its bonding system is going to be more stable. So that it is observed, it's phenomenal, when the metal binds with either fluorine or oxygen, it is going to show highest oxidation state. When it especially bind with an oxygen, it is going to show its highest oxidation state due to formation. The oxygen has the ability to form the multiple bond with the metal. Example here, manganese, Mn2O7. अरे Mn2O7 के हिसाब से एक क्वेश्चन भी 2026 जनवरी सेशंस में जेईई में भी एक क्वेश्चन पूछा. Right, we'll go. When it comes to the fluorine, it happened to the highest oxidant state. Stability of higher oxidant state. Fluorine stabilizes the highest oxidant state. Stability through high lattice energy, example COF3. High bond enthalpy, higher covalent compound VF5CRF5. Right? Arre beta, this is a live interactive session, expecting you to give the questions from your side. I'll give the answers, right? Yeah, that's good. Now when it comes to the oxygen, so instability of copper 2 plus iodide, copper plus 1 is going to be unstable in the aqueous solutions. There are 2 points I want to say. Copper plus 1 is going to be unstable. That is one remarkable point. Somebody tell me the reason why. Somebody tell me copper plus 1 unstable in aqueous solution. If anybody gives answer, in NEET examination, unexpectedly, just like tough paper unexpected in 2025 paper NEET, 2026 NEET paper come moderately little harder. Never expect NEET chemistry paper as easy as 2024 or so. 2025 standard दिया, 2026 को भी थोड़ा सा standard as well as little harder. Intentions are pretty clear. It is a hard warning. 2026 January session में JEE examination NTA ऐसे questions दिया है and NEET 2026 में ऐसे question और थोड़ा सा difficult questions भी आ सकता. But I want to confine the question paper is still in NCERT only. But the question comes in a different twist and turns will be there. Low hydration energy, yes. Coming to this, what happened? Copper plus na, it is going to be aqueous, it is going to be disproportionated copper 2 plus, and it is going to be copper, right? So this is very, very important, it is disproportionate. While copper 2 plus and I minus is going to react to give us copper Cu2 I2 plus I minus, because iodine is going to be a strong oxidizing, a strong reducing agent. That is the reason why Cu2 plus Cu I2 is not stable, okay, that's very important. Now the oxides of 3D metals, the ability of oxygen to stabilize these higher oxidant states exceeds, it is better than fluorine. So oxides are more stable than halides due to the formation of multiple bonds. The formation of multiple bonds जो है ना, we can say p pi d pi, multiple bonds you can say. And transition metals vary widely in their chemical reactivity. The study of standard electrode potentials is very required, and that is required standard oxidation potential or standard reduction potential, that decides the reactivity. When you say, when the metal in the N plus 2 form, this is the electrochemistry में हम देखा हुआ, but if you see these values here, and these values are going to be increased, but copper जो है ना, it is going to have plus 0.34, that is copper 2 plus 2 copper E naught value. So the reason is what? Why that reason happens? Yes, that is due to, so copper shows, all are showing negative oxidant state, but the copper shows positive SRP value. So enthalpy of atomization and ionization energies, when you compare, it has a high hydration energy, and second ionization energy is going to overcome this hydration energy. So as a result of this, first two ionization energy values are going to be positive and hydration energy value is going to be negative, and दोनों मिलके आपका SRP value positive होगा, that is very, very, very important. And बच्चों, here in plus 2 state, manganese shows D5 configuration, nickel with D8 completely filled T2G Eg orbitals, and zinc has completely filled D10. So they show the more negative values than the expected. This is the reason for the exceptional situations. Bacho, hope you are understanding, clear? Nice number of students are there in the today's class. So let us see what best we can do here. So they have paramagnetic behavior. So the paramagnetism and the color of the ions is due to presence of unpaired electrons in the d orbitals. That can be calculated, spin only magnetic moment, that is given as mu is equal to root over n into n plus 2. N is the number of unpaired electrons. If n value is 0, mu value is going to be 0, such compounds are said to be diamagnetic compounds. If n value is greater than 1, greater than 0, so mu is going to be greater than 0 and it is said to be paramagnetic. So n is the deciding factor. I will clarify Geeta Madhuri, no worries. Okay, now we can say Mn2 plus, it is going to have D5 configuration, so 5 n-paired electrons are there. You please follow the concept here, Geeta Madhuri. Okay, so that mu value is going to be root over 5 into 5 plus 2, and the answer is going to be 5.92. You need not have to calculate something value which is there, n value ka barabar hi hota hai. So that is the trick, you can say simply. After your class, can you please explain how to balance the equation in the oxidation number? Array, that is in the redox reactions mein aayega. And after the CBSE examination, I want to tell you how to balance these redox reactions. Okay, till then, Geeta Madhuri, you just try to be okay. So keep posting your doubts so that I can clarify that, right? So, bacho, those who are online, you see how Geeta is interacting, Alam is interacting. Okay, I am expecting. I mean, acidic medium and basic medium, दोनों भी कर सकता हूँ बेटा, कोई बात नहीं, ठीक है? Both will do. Both acidic medium and basic medium will do it. Okay, now the formation of colored compounds. Transition elements show the colored compounds due to unpaired electrons present in the d orbital. The compounds absorb some wavelength in the visible light and its complementary color is going to be transmitted. As a result of that, you see titanium 3 plus purple, chromium 3 plus green, manganese light pink, iron so 2 plus is yellow or brown, and cobalt 2 plus pink, nickel 2 plus green, copper 2 plus blue. So these are the fundamentally seen in the laboratory. If you go, all these colors are seen, and that colors, that what I explained, when an electron from the lower energy orbital excited to the higher energy orbital, due to its excitation, the compound is in a color. Bacho, you see copper sulfate, cobalt sulfate, potassium dichromate, you can see zinc sulfate, it is colorless white, because zinc salts are colorless. It's not a transition metal because it has a d orbital is completely filled. Samjhe? Right. Now moving ahead, they form complexes. Complex compounds can be formed by transition metals because of high nuclear charge, so that ligand can be stabilized, and it can have the variable oxidation state, availability of the d orbitals. Okay, so we have a separate chapter for that. Okay, reasons for complex formation: comparatively small size, high ionic charge, effective nuclear charge. Cobalt 2 plus is used in the lipstick to make our lips. Please clarify. No, cobalt 2, such an inorganic salts are not used in cosmetics, first of all, right? We take several dye substances that you can be used in the cosmetics. Fine. So cobalt 2 plus is not there for your lipstick. Okay, Betty? So availability of d orbital for bond formation. Okay, so these are the reasons for the why transition elements can form complexes. Hai na beta? Geeta, funny questions they are asking. Okay, so let us enjoy whatever the doubts they are giving. Transition metals show a catalytic properties better because they have the vacant d orbitals, incompletely filled d orbitals, and they have an adaptation to have the multiple oxidation state. Fine. And they have the catalytic properties, like iron 3 catalyzes the reaction between the iodide sulfate, thiosulfate. Okay, persulfate is converted into sulfate. And catalytic reactions, I don't want to show you the mechanism, but you can see N2 plus 3H2. Let us simplify the things. Gives rise to NH3. You can use iron as a catalyst. Haber's process of Synthesis of ammonia, fundamental reactions बचपन से देख रहे हो ना, use fundamental things. Okay. Let us not deviate the current context. Geeta? So our session and the concept, everything should have, it should have aligned with the actual phenomenal things. Okay, it's not, the class is about the chemistry but not the lipstick, right? And interstitial compounds. If you see the metal lattice, and you can see some non-metals are going to be trapped in the gaps of the interstitial species. This is, can be a carbon, this can be hydrogen, or this could be small atoms like a boron also. Fine. Such compounds are interstitial compounds. अरे बेटा, in the NEET examination interstitial compounds का properties का बीच में question आया था. You can expect the properties, the characteristic properties of the interstitial compounds. They have higher than that of the pure metals, and some borides approaches diamond like hardness, and interstitial compounds are very high, very hard and with high melting points. No, it's a doubt, let it be. I respect everybody's doubt. You are a kid, so I take a child doubt as a child doubt. I don't take it anything personally. Okay, beta? It retained metallic conductors and chemically inert. Interstitial compounds are chemically less reactive as compared to the normal metals. That is the point. And you can see oxides, oxoanions, K2Cr2O7, KMnO4 and everything. Let us talk about potassium dichromate. आज के लिए थोड़ा सा देना चाहता हूँ आपको. Potassium dichromate is a beautiful crystalline compound. You can't take your eye away. And let us see the preparation. So, steps, very important in organic. Steps in the preparation of K2Cr2O7. You are going to get the chromite ore. So, this is called chromite ore, FeCr2O4. This can also be written as FeOCr2O3. So, this is what is called as a chromite ore. Is fused with sodium carbonate, gives a sodium chromate yellow solution. It is soluble and filtered, and it is acidified, and it is going to turn yellow, is going to be turned into the orange to give a sodium chromate. Sodium chromate is highly soluble. Chemically inert means it will not react in a chemical reactions. Inert means it will not react. And this orange solution is saturated with the potassium chloride, so that insoluble K2Cr2O7 is crystallized. Okay, and this crystallized compound is separated and purified to get that potassium dichromate. Okay, beta. And its structure जो है ना, it is given as Cr2O7, and it is going to give us a CrO and Cr, double bond O, O minus, double bond O and double bond O and O minus. So, this is the structure of dichromate, and this dichromate है ना, it changes its structure with its pH, effect of pH. You can see effect of pH. Dichromate, it was yellow in color in basic medium. Okay, in the basic medium pH is going to be greater than 7. When you add a drop of an acid, it is going to give us orange in color. It is reversible if pH is less than 7. If you add sodium hydroxide, it turns yellow. If you add a drop of H to SO4, it become orange in color. So that is the effect of change in pH. So बच्चों, आज का time almost exhausted. I wonder how this session is completed. Okay, and we'll meet with more stuff. कल मिलेंगे हम कॉम्प्लेक्स कंपाउंड के साथ. Okay. In NEET UG examination, how will question will be asked in the preparation of K2Cr2O7? I will show you a compound A combined with sodium carbonate fused to give rise compound B. Okay, compound B is acidified. Like that, the questions will be there, right? Fine. So I will discuss all these things. So as the time is exhausted, I would close the session, and another session is in queue. Okay, we'll meet with more stuff tomorrow exactly 1:30 p.m. on complex compounds. So we want to conduct 2 sessions for the complex compounds. Get ready. So signing off, Suresh, Faculty of Chemistry. Please like the session, share with your friends, and subscribe to this channel. Thank you very much. Signing off.